How can you determine if a function has an inverse? So when you're looking at the function, what features does it have to have, and then if it has that, you're guaranteed it has an inverse. Recall that it needs to, there's a couple ways to state it. It needs to pass the horizontal line test. If the function passes the horizontal line test, so any horizontal line coming across hits it one time, remember the inverse is found by switching the x and y, so that horizontal line becomes a vertical line for the inverse function. So if it passes, the regular function passes the horizontal, the inverse will pass the vertical, and therefore it will have it will be a function. So what does that mean? If a function passes the horizontal line test and it passes the vertical line test, that means it is 1-to-1. The function is 1-to-1, which means for every x, there is one y. It also means for every y, there is one x. Find the inverse of this, i.e. let's write it in our proper notation, f inverse of x. We're given f of x equals 3x plus 2. So the first thing we'll do is write y equals 3x plus 2. We'll switch x and y, and then solve for y. X minus 2 equals 3y, y equals x minus 2 over 3, and then we'll write our final step, f inverse. We're asked to find the inverse. We're going to say f inverse equals x minus 2 over 3. Now for all these problems, for the homework, you're going to see this type of thing. We need to find f of f inverse of x, and we also need to find f inverse of f of x. So those are two different parts, and we're going to show that they're the same thing. We get the same result. So f of the inverse is x minus 2 over 3. We'll plug it in 3 times x minus 2 over 3 plus 2. So the 3's reduce. We get x minus 2 plus 2, and we get x. On this part, we'll have f inverse of f of x. That'll be 3x plus 2. So we'll say 3x plus 2 minus 2 all divided by 3, because right now we're plugging into this f inverse function. We'll get 3x over 3, which is x. Is that what we expect to get? We should, because remember, a function does something to the graph, and the inverse undoes it.